Okay, so this is lesson 2 of our study on evaluating functions. So just let's go ahead and look at number 1. Now make sure you looked at lesson 1 first before you start this one. So in lesson 1, we talked about function notation, how it comes about, why we use it. We also looked at some examples. In lesson 2, we're just going to go ahead and start looking at some problems rather than having a discussion about what function notation is. So let's look at number 1. You have g of x is 4x squared minus 3x plus 2. And let's suppose you're told h of x is 3x plus 1. Okay? So number 1, you're given two functions. So function g of x is this, and 3x plus 1 has the function name h of x. All right, so two different functions. Okay? So let's suppose in part A, I want to find, so you're going to find each of the following. Let's suppose in part A, you want to find g of 2. So just like we did in the previous lesson, in lesson 1, wherever you see the variable x, you're going to substitute 2. Now make sure you go to the right function. This is g, so make sure you go here and not here. See, that's h. Okay, so you got to go to your function g. So whenever you have more than one function in a problem, make sure you use the correct one. So this is g of x, this is h of x. So if I want to find g of 2, I got to go to function g. So this becomes 4 times 2 squared minus 3 times 2 plus 2. And then just using the order of operations, 2 squared is 4, 4 times 4 is 16, a negative 3 times 2 is a negative 6, and then plus 2. So 16 minus 6 is 10, 10 plus 2 is 12. So g of 2 is equal to 12, and that's our answer. Part B, let's suppose I want to find h of, let's say, negative 3 instead. Well, remember what that means. Now I've got to go to my function h. So this is your h right here. So make sure you go to the right one. So h of x is 3x plus 1. Okay, so that's important. And so now where we see the variable x, you're going to substitute negative 3 now. So this becomes 3 times my substitution, negative 3, plus 1. So now using the order of operation, I'm going to multiply before I add. 3 times negative 3 is a negative 9. Negative 9 plus 1 is a negative 8. So therefore, h of negative 3 equals negative 8. So again, the important thing to remember is that if you have more than one function, that you are using the right one. It's important. Okay? All right, C. Let's suppose in C, I want to find g of negative x. G of negative x. So wherever you see my, now remember, I got to go to my function g, right? So I go to my function g, which is this one here, and wherever you see the variable x, I substitute negative x. So if you need to rewrite it, you rewrite it. Just go ahead and rewrite this. So 4x squared minus 3x plus 2. So wherever you see the variable x, you're going to substitute negative x. Okay, so this becomes 4 times negative x squared, okay, minus 3 times my substitution, which is negative x, plus 2. Now let's use the order of operations. Now I need for you to remember, you got to be careful, you got to think. See, this is negative x squared. So negative x squared means negative x times negative x. Well, negative x times negative x is a positive x squared. So what this becomes now is 4x squared. So 4 times a negative x squared, negative x raised to the second power, becomes 4x squared. That's important. A negative 3 times a negative x is a positive 3x, and then plus 2. And so there's your answer. So g of negative x is 4x squared plus 3x plus 2. Okay? Now if you want to compare that with, let's say, h of x, do that. So let's say we want to find h of negative x this time. So here's h of x. So h of x is 3x plus 1. And so wherever you see the variable x, you would substitute negative x. So it becomes 3 times negative x plus 1. And so 3 times negative x is a negative 3x. So the answer is negative 3x plus 1. That's all you can do. So h of negative x will equal negative 3x plus 1. All right. And let's do one more. Let's do letter E. So letter E, for number 1 rather, letter E, we want to find g of 2 minus t. G of 2 minus t. So remember, this is g of x. Make sure you always go to the right function. So g of x is 4x squared minus 3x plus 2. So wherever we see the variable x, I'm going to substitute 2 minus t. So this becomes 4 times, I'm substituting 2 minus t. But I've got to square that. Minus 3 times, I'm substituting 2 minus t. And then plus 2. Now, let's go ahead and simplify this. So you're expected to go off to the side and figure out what 2 minus t times 2 minus t is. That's 2 minus t. Okay, because remember you're squaring this 2 minus t, so you got to FOIL it out. So 2 times 2 is 4. The outer is a negative 2t. The inner is also a negative 2t. And a negative t times a negative t is a positive t squared. Putting this in descending order, I get t squared minus 4t, because a negative t and a negative 2t and a negative 2t is a negative 4t, and then plus 4. That goes here. But remember, you're multiplying all of this by 4. So put that in parentheses, t squared minus 4t plus 4. So remember, all I found was this. That's all I found. So this is just this right here. Let's go ahead and distribute this part. Negative 3 times 2 is a negative 6, and negative 3 times a negative t is a negative 3t, a positive 3t rather, and then plus 2. Distributing, I get 4 times t squared is 4t squared, 4 times a negative 4t is a negative 16t, and then 4 times 4 is 16. And then rewriting everything else over. And now combining like terms, we get 4t squared. A negative 16t and a positive 3t is a negative 13t. 16 minus 6 is 10. 10 plus 2 is 12. And that's all you have. So the answer is g of 2 minus t is 4t squared minus 13t plus 12. That's your answer. Okay? Let's look at number 2. Number 2, let's suppose we had this for number 2. H of x is x minus 4 divided by x plus 3. So it's a different problem. Now don't confuse this h of x with this one, because we were looking at different problems. So this is number 2. Let's suppose in part A, you want to find h of 6. So again, where we see the h of 6, that's 6. So where you see the variable x, you're going to substitute 6. So I get 6 minus 4 divided by 6 plus 3. Simplifying this, you are expected to go further. 6 minus 4 is 2. 6 plus 3 is 9. And you cannot reduce, so there's the answer. So that means h of 6 is 2 nines. Part B, let's suppose you want to find h of 4. So again, same thing. So where we see the variable x, you substitute 4. So I get 4 minus 4. 4 minus 4 divided by 4 plus 3. So that's 0 over 7. You're expected to know. Don't leave it like this. If you leave it like this, we're assuming you don't know what this is. You are expected to know that 0 divided by 7 is 0. So the answer is h of 4 is equal to 0. C, let's find h of negative 3. So again, h of negative 3, wherever we see the variable x, you're going to substitute negative 3. So I get negative 3 minus 4 divided by negative 3 plus 3. The numerator, a negative 3 and a negative 4 is a negative 7. The denominator is 0. Again, don't leave it like this. If you leave it like this, we're assuming you don't know what it means to divide by 0. So remember, that's undefined. Or you can say does not exist. So then you would say this. You would say h of negative 3 equal, and in a blank, you'd say either undefined or does not exist, whatever you want to use. Okay? Because remember, we cannot divide by 0. And in D, let's suppose we want to find D. Suppose D was h of x plus h. H of x plus h. So where we see the variable x, let me go ahead and rewrite the function over. So here's my function. H of x was x minus 4 divided by x plus 3. So where we see the variable x, okay, this is what you're going to substitute. All right, so let's go ahead and do this. So h of x plus 4, I'm going to go to my function. I'm going to substitute. Remember, just kind of draw your arrows if you have to. So this x becomes x plus h. Minus 4 divided by This x here becomes x plus h plus 3. Then you combine like terms if you can. Notice that the numerator, they're ordinary like terms. The denominator are ordinary like terms. And you're done. That's really all you can do. You can't, don't cancel these x's out because those are not factors. Remember, you can only reduce factors. These x's are not factors because of that plus symbol. The h's are not factors because of the plus and the minus right here. All right, so you got to be careful. So the answer is going to be h of x plus 4 is equal to x plus h minus 4 divided by x plus h plus 3. All right, so that's number 2. Okay, let's look at number 3. Suppose in number 3 we had k of x is equal to the square root of x plus 5. So in part A, let's suppose in part A you want to find k of 4. So again, where we see the variable x, you're going to substitute 4. So to find k of 4, where we see the variable x and substitute 4, you get the square root of 4 plus 5. You got to go further. You have to go further. You know the square root of 9 to be 3. Okay? So k of 4 is equal to 3. Part B, you want to find k of negative 1. So k of negative 1, you're going to say, well, that's going to be the square root of, where we see the variable x, substitute negative 1. So negative 1 plus 5, square root of 4, which equals 2. Let's say in C, you want to find k of, let's go ahead and make this 9, k of 9. So k of 9 would equal the square root of 9 plus 5, which is the square root of 14, right? And you cannot simplify the square root of 14, so there's the answer. So k of 9 will equal the square root of 14. Let's say in E real quick, you want to find k of, let's say 23. So that's going to be the square root of 23 plus 5. So remember, where we see the variable, x, you substitute 23. So that's square root of 28. Now remember, you need to simplify the square roots if you can. So remember, the square root of 28 is the square root of 4 times the square root of 7. So the answer is 2 square root of 7, right? And so you're going to say k of 23 is 2 square root of 7. And let's do one more with this function. Let's find f. So let's say in f, you want to find k of 2x plus 1. So we go ahead and rewrite the function. K of x, remember, was this, the square root of x plus 5, right? So wherever we see the variable x, we're going to substitute 2x plus 1. So this becomes the square root of, remember, this becomes this. So 2x plus 1, and don't forget the 5. Simplifying the radicand, we get the square root of 2x plus 6. And that's all you can do. You cannot do anything else. It looks like, hey, it looks like it can do something, right? No, you can't. You're done. This is it. There's nothing else you can do. So k of 2x plus 1 is equal to the square root of 2x plus 6. Okay? All right, so that's the answer there. Let's look at number 4. Number 4, let's suppose we had this, number 4. We had f of x is equal to negative absolute value of 2x minus 1. All right, so the absolute value, so the expression 2x minus 1 is inside the absolute value bars, and there's a negative out in front. So in part A, suppose you want to find f of negative 3. F of negative 3. All right, now notice that's a number. So the numbers, whenever you're substituting just a number, you're going to end up with a number as your answer. So if you go back to all the ones we've done, you'll notice that. So where you see the variable x, you can substitute negative 3. So we get the negative absolute value of 2 times in parentheses negative 3 minus 1. That's how it looks. So you see how I substitute x with negative 3. Let's go ahead and simplify what's inside the absolute value bars. So it becomes negative absolute value. 2 times negative 3 is a negative 6 minus 1. See, that's right here is this. Negatives, you got to go further with what's inside the absolute value bars now. Negative 6 and a negative 1 is a negative 7. Okay? You have to, if I cover this negative out here, you have to recognize that the absolute value of a negative 7 is 7. But there's a negative out here, so the answer is negative 7. All right? So you just keep bringing this negative down out here. And so therefore your answer, f of negative 3, is negative 7. There's your answer. All right, part B. Part B, we have f of 4. F of 4. So again, where we see the variable x, you're going to substitute 4. So this becomes negative out in front of the absolute value bars. 2 times x, or 2 times x, I'm substituting 4, minus 1. So that's negative absolute value of 2 times 4 is 8. 8 minus 1 is 7, right? Like this. But then you got to recognize that the absolute value of 7 is 7. So to get rid of the absolute value bars, so the answer is negative 7. So f of 4 equals negative 7. All right, and then letter C. Suppose in letter C, you want to find f of x plus 1. All right, so let me go ahead and rewrite the function over. This was my function. All right, so wherever you see the variable x, I only see it here. This is what you're going to replace it with. So this becomes negative absolute value of 2 times in parentheses x plus 1, and then minus 1. Get rid of the parentheses. See, now we have variables. That's a little bit different. See, the way we did these, the way we approached these, what was inside the absolute value bars, is a little bit different than the way we're going to approach this, because this still have variables inside. So we're going to distribute. So I get 2x, 2 times 2 is 2, minus 1. The only things I can combine are the 2 and a negative 1. So it becomes negative absolute value of 2x, and then positive 2 and a negative 1 is a positive 1. And that's all you can do. See, here I can go further with that, right? Because that was a number I knew. We all know that the absolute value of 7 is 7. Okay? But this is a variable expression, so you got to leave it like it is. Don't get rid of the absolute value bars, because you don't know. You got to be careful, because sometimes x may be negative, sometimes x may be positive. You still have a variable there. So you got to be careful. So just leave the answer like this. So f of x plus 1 is equal to negative absolute value of 2x plus 1. That's all you can do. Don't distribute the negative through here, because that's not a parentheses. That's an absolute value bar. So be careful. Leave it like that. Some students get confused as to what to do next, and it's understandable. But the more you get through your college courses, if you ever come back, this will make sense a little bit more. Right now, some of this may not make too much sense, but just kind of know where to stop. Know how to manipulate things. You may make a little mistake here, but you'll get full credit. You know something, right? All right, but the understanding of when to stop and know what not to do gets better as you go through your math courses. All right, so that is going to be the end of lesson 2.